Good morning, everyone. I just thought I would walk through the final assessment with you, and that way you'll know what I'm expecting of you on this assignment. So there are 24 marks in total. It turns out that there are a total of 6 questions. Some of the questions have a part A and a part B, but every single individual question is worth 3 marks. All of the work must be presented in a clear, organized, and easy to follow manner. You know this by now in this course that I expect you to show all of your steps. Your work has to be submitted to me through email using photos or scans. Make sure they're readable. No later than Monday, June 22nd at 3:15. So at 3:15, that's literally everybody, that's the cutoff. I'm not going to be marking anything that comes in after that. You have a total of 2 weeks to complete this assessment, and there really ought to be no reason why you can't find time to do it. I haven't made it really intensive. Most of it should require very little review. And even though you have other commitments like other courses and jobs and your life, you should be able to organize your time so that you can successfully complete this assessment. Number 1, I would be remiss if I gave you a final assessment in calculus and I didn't ask you to find derivatives. So in question 1A, you have to find the derivative of a product. I guess that would mean you would have to use the product rule. It looks as though you're also going to have to use the chain rule in there. Remember that when we talk about things being simplified in this context, that means that you always have to factor everything completely and simplify the result that is non-factorable. As well, if you end up with any factors in a numerator or denominator, and I'm not saying you will here, but if you end up with factors in a numerator and denominator that are identical, you should cancel them. 1b is a relation. It's not a function, but of course it is a relation, and the only way you're going to be able to find dy dx there is to use implicit differentiation. I really hope that everybody knows exactly what to do with implicit differentiation, but if you don't, you may have to go back and review that. The second question is a very basic application of differentiation. You are given a function and a point on the function, and you are asked to determine the equation of the tangent to the function at that point. Again, something that we've done numerous times. What you are going to have to do is use calculus to find the slope of the tangent, and then use basic coordinate geometry to take the slope of the tangent and the point on the line and determine the equation of the line. Remember, in the general form of a linear function, ax plus by plus c equals 0, we always use integers for a, b, and c. We do not want any fractions there, and we do not want any decimals. Number 3 gives you a function, which is a volume as a function of time relation, describing the volume of water remaining in a reservoir as a function of time. The domain is, in this particular problem, 0 to 64. Everybody's questions will be a little bit different. In this one, the domain is only 0 to 64 because if you were to put 64 in for t, you would discover that that works out to 0, which means it takes 64 minutes for the water to drain out of the reservoir. You're asked to determine the instantaneous rate at which the volume in the reservoir is changing when the volume of water remaining is 8 liters. So I threw in the word instantaneous there just to remind you that when we talk about a rate of change, unless you're otherwise told, it is instantaneous. This is not a related rates question, it's just asking you to find a rate of change of volume with respect to time. One of the things you will notice when you look at this final assessment is I didn't put any max-min problems in, and I didn't put in any related rate problems. And the reason is I've evaluated you enough with those ideas. Number 4 is asking you to tie together concepts of acceleration, velocity, and position. The position in this question is actually an altitude above the surface of the Earth. And what you're going to have to do is use the acceleration to determine a velocity function and use the velocity function to determine an altitude function or a position function so that you can determine the altitude at a particular time. This is something that we just studied probably 2 weeks ago. Number 5 is an application of area, where you are going to have to determine the area between an upper function and a lower function. What that means, by the way, is you're going to have to determine where those two functions meet so that you can determine the lower boundary of the integral you're going to build and the upper boundary of the integral you're going to build. Don't psych yourself out with this question. It doesn't matter where the graphs are vertically, as long as one function, which by the way will be the linear function, is above the other function, which by the way is the quadratic function, in that interval, then you can always use the rule that we developed in class, which is the area would be the integral of the upper minus the lower functions from the lower boundary of x to the upper boundary of x. So it's a fairly straightforward question, a little bit of algebra involved. Number 6, 6a asks you to integrate 6x over 2x squared plus x minus 6 dx. If you're watching this video on Tuesday, then you do not know how to do this yet. In fact, you will not learn how to do this until next Monday's video, which I believe is the 15th. But the 15th is still 1 week before this assignment is due. So the technique of integration that you're going to want to use for 6a happens to be called integration of partial fractions. And you're going to have to wait until, like I said, Monday the 15th in order to find out what that's all about. But you will have lots of time to complete it, because once you see how it's done, it's not a difficult process. And 6b asks you to integrate, in this particular case, we have 5/4 e to the 2x multiplied by sine of 5x dx. You should recognize that as being something which you can integrate using the method of parts, where the integral of u dv turns out to be uv minus the integral of v du. So I hope that helps with a number of things. First, I hope it helps with understanding what I expect. And secondly, I hope it helps to trigger your memory and bring back some of those ideas that you're going to need for some of this earlier material. Anyway, have a great rest of the day, and we will talk to you guys soon.